Okay, today's topic is complex numbers and what students will be able to do. Okay, we're going to add, subtract, multiply, divide complex numbers and then solve with complex numbers. Complex numbers, again, they contain the imaginary unit. We've always been told that we cannot take the square root of a negative number. However, we can. It is now called the imaginary. It's the letter I. So when I take something like I equals the square root of -1, and I square both sides, and the square eliminates the square root, thus I squared equals -1. Definition of a complex number. If A and B are real numbers, the number A plus BI, A plus BI is a complex number and is said to be written in standard form. It's a complex number because A is a real number and I is an imaginary number. So putting in a real plus an imaginary makes it a complex. Now, if B is 0, then it's just going to equal A, a real number. If B doesn't equal 0, then it's called an imaginary number or a complex number. If A is 0, or if the number is just ABI, it's called a pure imaginary number. Okay? Pure imaginary number. Let's work with them. We work with i's the same way that we work with any polynomials that we deal with. First, when we simplify, we're going to add the real, keeping it real, the real numbers, 5, and then I have 1i plus 3i plus 4i. So we add the same way. When we subtract like we do with any polynomial. We have to distribute that negative. So it's -2 minus 3i. So 3 minus 2 is 1. I minus 3i is a minus 2i. We multiply the same way we do with any binomials. Distribute, so that's 6 plus 9i. All right, and then we distribute again. We distribute the I this time here, so it'd be plus 2i. Now 3 times 1 plus 3, I times I is I squared. What do we know about I squared? I squared is equal to -1. So this expression here is the same thing as saying 3 times -1. So the whole thing would be 6 plus 9i plus 2i minus 3. So now combine like terms. 6 minus 3 is 3. 9 plus 2 plus 11i. Standard form. Okay. Multiply this out. 3 plus 2i times 3 plus 2i. Distribute. 9 plus 6i plus 6i plus 4i squared. Again, we have that I squared. So that makes that a -4. 9 minus 4 is 5. 6 plus 6, 12i. And number 5 here, it's just simplifying. If we have the square root of a -4, that's the same thing as I times the square root of 4. I pull out that I first for the negative times I square root of 16. Okay, what was the square root of 4? 2. Square root of 16 is 4. So now we multiply. We have 8i squared. And what does I squared equal? -1. So the final answer is -8. Okay, so let's multiply 3 minus 5i plus times 3 plus 5i. So that's 9 plus 15i, distributing, minus 15i, minus 25i squared. Okay, well, what does this become? That becomes, here, that becomes plus 25. So 9 plus 25 is 34. Positive 15 and negative 15, 0. So what happened to the i's? When you multiply, the i's zero out. Okay, they're eliminated. These are called complex conjugates. So if I'm looking at the complex conjugate, the real number always stays, or I say keep it real, change the imaginary. Okay, so the complex conjugate says just keep it real, change the imaginary. Keep it real, change the imaginary. Keep it real, change the imaginary. Keep it real. There really is on number 7 no complex conjugate because it's a real number. So we don't have a complex. Because it's already real. All right. We use the complex conjugate to divide imaginary numbers. Conjugate. So we use the complex conjugate to simplify division. Now, use the complex conjugate of the denominator. So the complex conjugate of the denominator would be 4 plus 2i. Now, if I multiply the denominator, I must also multiply the numerator. So we go ahead and we distribute like we do with everything. So let's do the numerator first. That would be 8 plus 4i plus 12i plus 6i squared. Let's do the denominator. We have 16 plus 8i minus 8i minus 4i squared. All right, so now let's deal with it. Okay, the I squared we know is negative 1. So negative 1 times 6, negative 6. We know the I squared down here is negative 1. Negative 4 times negative 1, positive 4. All right, so let's add our reals. 8 minus 6, 2. 4 plus 12. 16 plus 4, 20. 8 minus 8, 0. Now, since every number, okay, we've rationalized, what this means is we've rationalized the denominator, we've gotten rid of the imaginary numbers in the denominator, and that's the point. Now, if we look at every one of these, 2, 16, and 20, we notice, oh, look, they're all even, so we can simplify it even further. They're all divisible by 2. 2 divided by 2 is 1. 16 divided by 2 is 8. 20 divided by 2 is 10. That would be our final answer. Okay, let's do another one. Complex conjugate. Again, we're going to look at just the denominator. let's multiply it out. 2 times 2, 4, plus 2i, plus another 2i, plus I squared. Multiply it out. 2 times 2, 4, plus 2i, minus 2i, minus I squared. That's plus 1 times a negative 1, so that makes that negative 1. This is negative 1 times negative 1, so that makes it positive 1. Let's combine our like terms. 4 minus 1 is 3. 2 plus 2, 4. 4 plus 1, 5. 2 minus 2, 0. I've rationalized the denominator. That's my final answer. All right, so we can work with complex numbers. We can also solve now for imaginary roots of a quadratic using the I value. So if I'm solving number 1, first thing I'm going to look at is it's missing the linear term, so I could use the square root method. X squared equals negative 16. Take the square root of both sides. X equals plus or minus square root negative 16. First thing I'm going to do is pull out the I. Okay, so that's the negative. Now what's the square root of 16? It's 4. We write the number in front of the I because that's standard form. That's our solution. Now, I'm going to look at this next quadratic. It has a linear term. There's a couple ways I can approach this. First, is it factorable? No. So since it's not factorable, I'm going to either use completing the square or quadratic formula. I'm looking at that middle term, the linear term. It's even, so I'm going to complete the square on this one. Okay, I'm going to move my constant over. Now I take my 4, divide by 2, and square it. So I'm going to add 4 to both sides. This is now factorable to x plus 2 quantity squared equal a negative 4. Take the square root of both sides. Now I'm going to pull out the I. And what's the square root of 4? 2. So that's going to end up being plus or minus 2i. Now let's bring over our constant, subtract 2 from both sides. And I have a complex number as my solution.